Okay. Let's go to number 7, focus 21, sound waves. The figure shows sound source S. There's a sound source S moving from observer P towards observer Q. P and Q are observer. What is the effect of the motion on the wavelength of the sound received by P and by Q? Okay, what's the answer? Yep. What's the answer? Cannot study at the end one. When the exam comes, you study at the end, you cannot master that fast. Not like STPM.
A.
A. Okay. Just remember this picture. This one shorter wavelength. Right? This one longer wavelength. That's all. Okay, good. Number 8. A cyclist approaches a songbird on a tree at a speed of 10 meters per second. If the bird sings at a frequency of 420 hertz, what is the frequency heard by the cyclist? Okay. What's the answer? We need to memorize the formula. That formula. Right? This one, the observer is the one that's moving. The sound source is not moving. Okay. So cyclist approaches, so the observer is moving at 10 meters per second towards the sound source. So the two are the source of sound and the observer are in the same direction. So that's why you choose at. And this is just the V is just the speed of sound 10 times 400. This is the frequency of the bird. Okay, see, good. The intensity of sound at a distance R from a point source is I, and the amplitude of sound wave is A. What is the intensity and wave amplitude at distance 2R from the point source? Okay, what's the answer?
Boy.
Right? Use this formula. I is inversely proportional R square. I is proportional amplitude square. And I R square is proportional to A square. So you can take R across there and take square root. It's a constant. So we use our IR square is constant.
Teacher.
Yeah.
Before I finish, teacher, dimension or extension is what, teacher?
Say again.
Dimension of extension.
Extension is just length only, or?
L, right?
Ah.
Not M square or L square, right? Yeah.
No. It's just length only. You mentioned length only. Extension.
Dimension one.
And
it's meter lah.
Just L only or meter.
Oh, okay. Thank you, sir. That's it. I'm doing the question for SEM 1 last. So that's why I asked.
So you want intensity vary with distance. That's the old one. That's the old one. This is the new one. Right? You just use I2 square, R2 square equals to I1 square, R1 square. And then you can just rewrite that and put in your value. Initial one is R. You change the new one to R. And the whole thing square. Initial one is I. So it's I over 4. Then amplitude. Using this formula. Okay. I take my R2 across there. And put in your value. Initially is amplitude A. This is R. It's 2R. So A over 2. So answer is B. Okay. Yeah, I give you the answer. What's the answer for this one? Give you the answer already.
Which one?
Why I didn't? Okay, sound of a certain frequency travel along the axis X. The graph below shows the variation of displacement Y with distance X of the air molecules from the point O. So there's a displacement, that's the distance moved by the wave. Each graph shows a variation with pressure, change delta P with distance X from O. So just remember, this part is the compression, high pressure. This part is the rarefaction, low pressure. Okay, so what is the answer? Yep, what's the answer? Yep. Didn't do homework.
C.
Okay, right. Know that this is a high pressure, both atmosphere, both zero. Right? They treat zero as the no change atmospheric pressure. And then Q, low pressure, rarefaction. So, okay. Or you can remember that X leads P by pi over 2. Then look at your, look at this is your 0. That's your 0. That's a pi over 2. Either you know how to read or you memorize that. Either way. Okay. Answer C. What is happening? Okay, number 11. What's the answer?
Boy.
Two sources. Do you want me to show you or you are okay?
Sure, teacher.
Two sources of sound P and Q emits sound of frequency
Teacher,
600 Hz.
one more thing, sir.
Yeah.
Oh, no. Sorry, teacher. You tell first, then I tell later.
Two sources of sound P and Q emit sound of frequency 600 Hz. An observer move towards, right? These are the source. The observer is the one moving with that speed there. The speed of sound in air is given. What is the frequency of the beat detected by the observer? Okay, you have to use this formula. The sound source is not moving, so you can treat it as 0. So for the source and P is moving towards, so frequency when observer moving towards P, right? The two of them, remember the sound source is moved. The sound source is not moving, the observer is moving. So move. These two, for P, the two are moving towards each other. Right? The sound source and the observer moving to each other, so you took a positive. Okay, so that is of the frequency observed by P, and then you choose a positive and put in your value. Right? That's the speed of sound. Speed of sound. That's the observer moving. That's the speed of observer. And then there's the frequency of the sound. So it's 660. Whereas for O, right, the sound is moving to the right, but the observer moving to the left. Sorry, I think I've done something wrong. The observer is moving. The observer is moving to the left, whereas the sound is moving to the left also. Right? That is the sound source from O, not from P, from Q, sorry. From Q is moving to the left. The observer is also moving to the left. So that's why we subtract. They are both in the same direction. That's the reason why we subtract. And put in your value and calculate out. And then the bit is just take the difference between the two. Okay. B. Right? A lot of problem on Doppler effect. The bus is traveling on a straight road at a speed of 54 km per hour, while an ambulance with its siren on is approaching it on. The actual frequency of a siren is 1.4 kilohertz. If the frequency heard in the bus is 160 kilohertz, what's the speed of the ambulance? Sound is given. So as I always say, memorize the formula, know how to use it. Observer is in the bus, so observer is moving. Right? Change it to meter. 54 kilometer over 1 hour. Change it to meter. We just times another 30. Then 1 hour. 1 hour is 3,600. So what's your answer? Didn't do homework. Yeah.
This one number 12.
Didn't do homework lah.
C,
Suspect.
teacher.
Huh?
C.
Didn't do homework, I suspect lah. Right? Convert to kilometer per hour to meter per second. Right? Have a rough idea what is the situation. There's your siren. There's your bus. Right? You can think of this as your ambulance. Okay. So both of them are moving. Right? Observer in the bus moving. The siren is also moving. So you have to use that. And since they are moving towards each other, you have to choose positive. Right? The sound source and the observer moving to each other, positive. The sound source and the direction of the speed is in the same direction. So put in your value. Sorry, it should be negative here, not positive, because both are in the same direction. Okay, and then your frequency, it doesn't matter. You put kilohertz, you get kilohertz, that's all. And then this is what is given. Observe. Actual frequency is 1.4. Frequency heard by the person in the bus is 1.6. And from there, you can calculate your VS. Right? Take this one, cross multiply. And then take this one down. VS is 28 meter per second. Right? You can see that they are very deceiving. If you straight away put A is wrong already. You have to convert it back to kilometer. 28 over 1 second. Right? Meter to kilometer is 10 to the power minus 3. 1 second is 1 over 3,600 hour. Okay, so answer is C. Okay, anything not clear? Friday we'll start a new topic. Optics.
Oh.
Unless you got question to ask.
No, so far no.
Okay. Actually, you don't need to calculate so tediously. Right? From 28 compare 28 and 15, it's almost double. Right? So it's 54. Answer cannot be 65. Answer must be almost double, slightly less than double. So it cannot be this one. So answer is C. Right? Rather than go and calculate, because objective one, they don't want a fixed answer. They want you to get the right answer, that's all. So no point.
Wait, I don't understand what you mean by double, not double.
This one is 15.
Okay.
But this one is 28.
All right.
So it means that it cannot be 54. It must be double 54 lah. Yeah, because it's 15
Yeah.
This 15, this is nearly 30
Yeah.
So it means that this is double that lah. Slightly less than double lah. Then it choose these two answer only. This
Almost
is
going to be double lah.
slightly less than double. You can see that
Slightly less than double.
So 54 is 108. So that's the best answer.
Oh yeah lah, 122 cannot because already fixed already the 28.
It's more than double already.
Yeah.
Sometimes you don't need to calculate exactly. Don't waste your time.
No, it's almost double but fixed lah. Yeah.
Almost double but slightly less. So you look at double. Double is 108. So this is the best answer.
An exact answer.
Don't need
unless
exact
if
answer.
it's a round off answer,
Unless
then only
you want an exact answer lah. Right? But in objective, you don't need to get exact answer. You can roughly estimate. Sometimes save you the time.
Okay.
Okay, what's the answer for this one? Yeah.
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 What do you call that? Sorry. Last week my exam result came out.
So how is your result like?
Bad, very.
A stationary sound wave is set up in pipe open at both ends. The sound emitted is the fundamental frequency. X, Y, Z are particles along the axis of the pipe. Which statement about the motion of the particles X, Y, and Z is true? Okay, you cannot play already. As I say, you have to put in the effort to understand what I teach you and do your homework. At the same time, you start revision already. If not, you may not do well.
Oh, no. If I start 2 weeks after this means cannot already.
Okay, so what's the answer for number 13?
Okay, number 13. Donkey.
Donkey. Oscillations of particle X and Z are in antiphase. X and Z in antiphase, okay. Right? Roughly understand that is your mode of vibration. Right? That is your fundamental. You want fundamental. Right? Antinode. So if that is up, this must be down. So antiphase, correct. Right? So this displacement distance graph, you can look at the blue one, or you can look at the other one, the gray one. X and Z are antinode. X and Z are antinode. So particles are maximum displacement. Y is a node. Particle at rest. That one you must know. That's your Y. So answer is donkey, correct? 14. An observer approaches a stationary source that emits sound of constant frequency F. Which row describe correctly the frequency and intensity of sound heard by the observer as he approaches the source? Okay, what's the answer?
Boy.
Boy. Okay. Memorize the picture. And then remember your intensity is proportional to distance square. So observer sees shorter wavelength or higher frequency. Right? Intensity start to increase because the distance start to decrease. Okay, boy. A police car with a siren of frequency 1000 Hz on travel at a speed of 20 meters per second. A car traveling at 15 meters per second move towards a police car. If the speed of the sound in air is 340 meters per second, what is the velocity of the car relative to the police car? And what is the frequency of the siren heard by the car driver? Okay, as I said, memorize the formula. Police car with siren on, that's the frequency. That's the speed of the police car. That means that's the speed of the source. Car traveling 50 meters per second towards the police car. Right? The two are approaching each other. Right? Roughly, imagine your head, observer and source are moving towards each other. One is 20, one is 15. Right? F0 is the observer. So speed of car relative to police, as long as both of them are approaching each other, you just add the two speed, that's all. Okay, that's why it's 35. Okay, so for this formula, the observer and that one is moving towards each other. So that's why this top one we choose 15. But the source is moving to the right. The sound is also moving to the right. So that's why we choose negative, since both are in the same direction. And calculate out. The answer is donkey. Okay. Anything not clear? I think we take 5 minutes break. Our time is almost up already. Anything to ask?
No, so far nothing.
Okay, we take 5 minutes
Just
break.
that yeah, you know, just
can,
that stress studying the physics actually.
can try the question that you haven't done yet. After that, we try
Okay.
the structure and essay. Okay.
Okay, sure, sure. Thank you. Sure.
Yeah.
The last week class feel like just should replace lecture. At least I
No
can
need
ask
to replace.
questions.
We still got the time. It's better you spend the time doing your term 1 and term 2. And then you got question to ask, then you can have an extra class. Other than that, no point in going too fast. I would rather spend time letting you have more time to do your homework. Okay.
Okay, thank you.